So how do we find these indefinite integrals? Well, sometimes we will need to rewrite an integral first so that we can use the power rule for integration. So for the first one over here, a lot of people look at that and think, oh, they jump right in and use the power rule. But we cannot do that here because we have what's called a composite function. So instead, what I would do is I would write out that binomial twice and multiply. So off to the side, I'm going to multiply 5x squared minus 3 times 5x squared minus 3. And when I multiply those, I get 25x to the fourth minus 30x squared plus 9. So I'm going to come back up here to the indefinite integral, and I am finding the integral of 25x to the fourth minus 30x squared plus 9 dx. Now that I've rewritten it, now I can use the power rule. So I will add 1 and divide by 5, so that would give me 5x to the fourth minus, I would add 1, which is 3, and then divide by 3, which is minus 10, x to the third, plus 9x, and do not forget that constant. We always need to have that constant. And that would be my answer here. Now let's look at the second one. So here we have a quotient. A lot of people think there is a kind of a reverse of the quotient rule, but there is not. So the first thing we need to do is rewrite it. For this one, I'm going to split up the fraction. So I'm going to rewrite this as x divided by square root of x plus 7 divided by square root of x. Now I'm going to rewrite those square roots of x as x to the 1/2. From there, for the first one, I'm going to simplify this fraction by subtracting exponents. That would simplify to x to the 1/2. And I can rewrite the second fraction as 7x to the negative 1/2. All right, so I've now rewritten the integral. So I want to find the indefinite integral of x to the 1/2 plus 7x to the negative 1/2 dx. All right, now that I've written it as a polynomial function, now I can use the power rule for integration. So I'm going to add 1 to 1/2, and that gives me 3/2, and then divide by 3/2, which is the same as multiplying by 2/3. Plus, I'm going to add 1 to negative 1/2, and I get x to the positive 1/2. I'm going to divide by 1/2, which is the same as multiplying by 2, so that gives me 14. And once again, do not forget your constant. If you're liking this video so far, make sure to click subscribe right now so that you're notified when weekly videos to come out to help you in your calculus classes. Now for the last one. Again, you've got some product here, and a lot of people think there's a way to undo the product rule. But instead, what I would do is I would rewrite this integral so that we can use the power rule for integration. So I'm going to rewrite the cube root of x as x to the 1/3, and then I'm multiplying that by x minus 6. Now I'm going to distribute the x to the 1/3. When I distribute it, I'm going to add those exponents. So this becomes x to the 4/3 minus 6x to the 1/3. And now I can rewrite my integral using a polynomial function. So I want to integrate x to the 4/3 minus 6x to the 1/3 dx. And look at that, now I can use the power rule for integration. I'm going to add 1 to 4/3, that gives me x to the 7/3, divide by 7/3, which is the same as multiplying by 3/7, minus, going to add 1 to 1/3, that gives me x to the 4/3, divide by 4/3, which is the same as multiplying by 3/4, that would give me 18/4, or 9/2. And again, do not ever, ever, ever forget that constant. All right, thank you so much for watching. If you found this video useful, make sure to click subscribe right now so that you are notified when my weekly videos come out.